Thank you for joining us for the Utah Energy Code and Building Science Lunch and Learn Series training sponsored by Dominion Energy and Rocky Mountain Power. My name is Becky Robbins, and on behalf of the Governor's Office of Energy Development, welcome to our free Lunch and Learn series, offered the second Thursday of every month and live streamed so you can attend in your office. It goes without saying the utilities help us with more than just training. They also help us with incentives, and you can find incentives for new construction projects at wattsmart.com and thermwise.com. I do want to let you know that our next Lunch and Learn will be Thursday, November 8th from 11 to 1, and we'll be discussing air sealing multifamily buildings to meet energy code. We are focused on this topic this month due to the increased requirements for infiltration when it comes to these types of buildings. Those go into effect January 1st, 2019. We are also planning a full-day training with building science expert Mark LaLiberte with construction instruction. That is looking like it will be December 5th. I will be posting more about that. Please be sure to look for our email blasts. If you don't get those, we're happy to put you on our list. Or check out our new website, which is utahenergycode.com. I just want to thank our community partners, the Home Builders Association of Utah, who has made energy code training a priority for its members, and Salt Lake Community College's energy management program that is integral to the building our workforce needed for the construction industry. You'll hear more from Alyssa Kay from the Energy Management Program in just a minute. But I did want to point out, for those of you online, you will see on the utahenergycode.com/live stream page, there are the documents for today's presentation. That includes the presentation itself and manual J, S, and D that are also posted on the website. I also want to let you know that on our website, if you click on residential, you can find things like our residential compliance paths. What are the different ways that builders can comply with energy code? You can also find the amendments to Utah code, as well as the air sealing checklist, and most importantly, our HERS rater list. And these are the players in our building industry who are supporting builders every day to build homes to meet energy code. And you can find more information about the HERS raters who work in Utah on our website. I just want to let everybody know the plan for today. Brent Ursenbach will be giving our presentation. We will be taking a break at noon to provide lunch to those attending in person. For those online, you will see a screen that will just be saving the place and letting you know we'll be right back. We'll be passing out lunch and return around 10 after. If you could please, everyone in the audience, silence your phones. If you need to take a call, please go in the hallway, and you can find any services on this floor. We'll start with a brief introduction by Alyssa Kay, the Program Manager of Salt Lake Community College's Energy Management Program.
Thanks, Becky. So we're really excited to be able to host these trainings here on the Miller campus. This is where we offer all of our classes in energy management. And you know, it's really important that you're here. Thank you for being here. Every bit of energy that you save makes a big difference. So if today's training is going to be great, it's brought to you by Brent is going to be teaching it. Brent is a former instructor and has actually helped us a lot with the curriculum development in the energy management program. And we miss him. We hope he comes back. But in the meantime, it's great that he is out here, you know, spreading the word and sharing his knowledge with all of you. We have a lot of great instructors in the energy management program, and all of them are professionals that are currently working in the industry, so they know the state of technology and are able to teach our students current industry technologies. So coming up in January, we start our residential building energy course, and then in March, we begin our HVAC energy efficiency certificate. So if those are things you might be interested in, take a flyer up here, give me a call, send me an email, let me know, and I'll be happy to answer any questions you may have. All right, thank you so much.
Okay, I will now go ahead and introduce Brent Ursenbach. He's an energy and mechanical code specialist at Code Consultants. He's an ICC combination inspector and a CBO and lead accredited professional. Many of you know him because he has done many trainings in Salt Lake area because of his work as a building inspector for Salt Lake County. Before that, he was an HVAC contractor for many years, and he's a past president of the Rocky Mountain Gas Association. So today's topic is perfect for Brent to give, since he's an expert in residential HVAC. I'll pass it over to you now, Brent.
Thank you, Becky, and good morning. It's great to be here again. I like this 2-hour thing, lunch and learn, versus all day long, and I think people attending it's a little bit better for you too, because an all-day class gets pretty long for everybody. But we're still going to be doing some of those. I know that some of you come in a few minutes late. That's great, and there'll be others coming in. I'll mention it again. When we break for lunch, just check in with Alyssa so that we can make sure we have everybody recorded that attended. Like Becky said, and most of you know, I did retire from Salt Lake County in May, and I now work part-time for West Coast Code Consultants, which is a whole mouthful and hard to say, so we just call ourselves WC3. And some of you know about Chris and the people at West Coast, and I do work part-time for them, helping them with plan review for some interesting projects around the western United States. And with my work with WC3, they also have made a similar agreement that the county had with the state for me to provide these types of trainings. And so the State Office of Energy Development, through a contract with WC3, and Becky works with them too, and Rocky Mountain Power, Dominion Energy, and funding from DOE makes this possible so that we can do these at virtually no cost to you. I'm available to answer questions and such, and I'll be very candid with you. I am trying to be semi-retired, so I don't answer my phone all the time. So email is by far a better way to ask me a question. And it's good for you too, because if you have to take the time to put it down in writing. In fact, I have people call me all the time or send me an email and said, I was going to call you and ask you a question, and I sat down and started writing out my question and looking up in the code, and I found my answer. And I'm not saying I don't want to help you, but if you put it in an email, then I can answer, and it'll usually be at night, because I am trying to spend some time with family and such. And in fact, we do have, Becky mentioned it, we do have a website, and I'll have the website in my slides here, Utah Energy Code, code.com. And all of our presentations from the past year are on there. All the handouts are on there, and we are now going to start putting on there Q&As. Someone asks a question, we'll list the question, and then we'll list the answer. And so what we're trying to do is make it easy for you to find answers to some of those questions that get asked all the time. And I'm going to go back and find some of the previous things that I've responded to or that someone else has responded to and locate those on that website. And I think that'll be really useful for us as we try to get our head around what's required when we're building according to the Energy Code. Now, today's focus is on mechanical, or the HVAC requirements in the IECC. Now, the International Energy Conservation Code, this book, is divided into two parts. The first part's commercial and the second part's residential. The residential part of this book, and I know many of you know this, is exactly the same as Chapter 11 in, Chris, you want to hold up your IRC? That book right there. Chapter 11 in that book is the same as the residential requirements in this book. And then this little handout, which we have up here, but is also available on the website for your reference, includes all the amendments. And if you look at a page in here that has red writing in it, that's a page that has amendments. So these pages come right out of the code. So you can refer to that to see what those amendments are. And generally the amendments take a little bit of the aggressiveness of the code out. They weaken it a little bit, but it makes it a little simpler to comply. And then it steps you into some of those requirements. So the residential energy code, for the most part, is an envelope-based code. So what I'm saying by that is we have a home and we have the thermal envelope. That's the line of insulation and air barriers and everything that encapsulate that home. And so the first path to comply with the code is what we call a prescriptive path, and we just have a recipe. And it says, for whatever climate zone you are in, you have to have, for instance, R49 in an attic, R21 in a wall, R30 in a floor, and you just have a list. The windows have to be 0.32 or whatever on the U factor. And if you meet every one of those things, you meet the code prescriptively. You meet every one of those. Well, that's not always that simple, and you might have one component that's weak and one component that's strong. And so we can do what we call a UA trade-off, and that is what we know as res check. And maybe some of your jurisdictions, or maybe some of you that are out there as building inspectors, code enforcement people, want a res check for everything. Well, that's not what the code says. The code says that you have options. So you technically shouldn't have to do a res check for every home. It's sometimes the easiest. So the recipe prescriptive UA trade-off, where you can trade a weak for a strong. Simulated performance, that's a model, that you do a model on your building, compare it to a model on a building that met that code, and generally if the energy consumption is no worse, then it complies. And then a new path, the ERI or HERS rating. You have a HERS rater rate your home, and if you hit a certain score, you pass. Now the reason I bring these up, well, one more. We have a fifth option in Utah, and we have an amended res check or a modified res check for Utah that was made in 2012 that you can still use to show compliance with the code. However, you have to pass right now by 3% and 4% starting in January of next year. What this option allows you to do is still take an equipment trade-off. Previous versions of res checks, when I say previous, 2006 res check allowed you to build a less aggressive or poor performing envelope, but get credit for the 95% efficient furnace. And so you say, well, I'm going to build kind of a poor envelope, but I'm going to put in a better furnace or a better air conditioner, and so we're going to trade it off that way. Well, the code development process chose to eliminate that because you have one shot to build a good envelope, don't you? Once you've built the walls and stuff, it's pretty hard to make it better. And so that was removed in 2009 by DOE and ResCheck. Well, we have the home builders that really want to keep that equipment trade-off, and so by legislative action, we've kept it in there with a ResCheck that still allows that. That being said, I'll be honest with you, this is a weaker pathway. This pathway is not equal to the other pathways. The performance is a little bit less on that pathway than it is the others. Whether you want to call it a loophole or whatever, but it is a pathway that you can use to comply with the code. However, it does increase every couple of years how much you have to pass by. For all intents and purposes, this really could go away, in my opinion, because the ERI, the Energy Rating Index, or the HERS rating, also gives you credit for equipment efficiency. In fact, it gives you credit for high efficiency appliances. It gives you credit for virtually everything that uses energy within your home. So this is really a broad look at the whole home and the energy consumption in the home. And it's really the direction that we really would like, I personally, and a lot of people would like to see the energy code go, where we really look at the total consumption of energy in the building and not focus just on the envelope, or not focus on the envelope and maybe the furnace and air conditioner, but focus on the whole package. And so this gives you credit for everything you do. And it, in fact, this path actually allows my friends in Washington County that want to build a home with budded glass, which is half-inch thick glass that they just butt them together and seal that seam, which would never comply with any of the other paths because the glass performs so poorly. But they can put a wall of butted glass so they have that view of the red rock and everything, and go be real aggressive in other parts of the energy consumption in the house. And so it gives you the very most flexibility. It's a beautiful path to go down, and in fact, my dream is that eventually every home that ever goes on the MLS, every new home, every home that goes up for sale, has that rating to it so that you as a home buyer can truly look at the home and compare it to another home, because you're going to have an energy score for that home. Steve got a thumbs up over there. But it's the best way to do it, to where we can really look at the energy consumption. Now, circling back to what we're really trying to talk about today is the HVAC side of it. We can build a great envelope and screw it all up with a poor HVAC system. We can waste a lot of energy with a poor HVAC system that we really don't need to. And in fact, we have changed the home we build today, even with the few of the weakening amendments, is so much better than the home we built 10 or 15 years ago, that we simply don't need that huge HVAC system. The analogy, and some of you have heard it before because there's lots of familiar faces in here. I come from a family of 7 kids, so mom and dad and the 7 of us, so there was 9. Now, if we wanted toast in the morning, mom would do what? Pull out the top rack in the oven and spread bread out across that whole thing and turn on the broiler and make toast. Well, if my wife and I want to make toast, there's just the 2 of us, we don't need to use the broiler to make a piece of toast. What do we use? We use the toaster that's properly sized to make 2 pieces of toast. And guess what? It uses a whole lot less energy than the big broiler in an oven. That fair? Really, that's an analogy that we can kind of compare to what we do in a home if we don't look at proper sizing. So those of you that are builders that are feeling the pain, and have been for a number of years, of having to provide a load calculation and a duct design and all these things as part of your process of building, those of your code officials that are trying to interpret those, it's really important that we build, when we build a home, that we have a legitimate design for an HVAC system so that we can properly heat and cool that home and be efficient. So we're gonna focus on those. So in these 3 paths, there is a mechanical component where we do actually look at the HVAC in the system. This one doesn't really give you credit for higher efficiency equipment, but it does look at the equipment. But these 2 paths definitely do, and this one really looks at the whole thing. Now you have a sheet like this if you want more information on this, and it kind of tells you a little bit of the pathway through these 5 different paths. You know, the energy code, I know people complain about it and hate it, and they don't want to be told, you know, how much energy they can use in their home and such, but the energy code is the most flexible of any code we have. Think of any other place in the code that it gives you 5 paths to show compliance to the code. We don't have that. So we have real flexibility in there so that you can build the style of home you want. Whether you want to build it out of straw bales, or you want to build it out of insulated concrete forms, or you want to do wood frame or whatever, we have a path that you can go down to do that. This prescriptive path that I talked about here has what we call a prescriptive table. And in Utah, we have these climate zones, 3, 5, and 6 that are climate zones. And here are those recipe components: 0.32 on a window, 0.55 on a skylight, 49 in an attic, and so on. And if you meet those, you comply. Now there's something I want to throw out here right now, and I know there's some builders that are here and maybe listening on board, and plan reviewers and HVAC people. If you are going to use the prescriptive table, and those are the values you're going to use, if you're going to build a home and you're going to put 0.32 windows in it, 49 in the attic, R20 in the wall cavities, and so on, and you turn in a res check, or you turn in a, or you tell whoever you're working with, I'm going to do it prescriptively, those values need to be on the plans. If they're not on the plans, how are we going to make sure that the building's going to get built that way? Further, if you're having your HVAC contractor, or if you're the HVAC contractor, and you're doing a load calculation, you need to know the values that are planned on in building the home. The biggest thing I encounter on residential and commercial plan reviews that I do is I get a res check or a comm check or a load calculation, and the R values and the U factors are completely different on the plans, if they're even there, than they are on the energy compliance document. How do we know that it's going to get built correctly if we don't have that consistency across all the documents? And invariably, the HVAC guy is asked to do a load calculation, and he doesn't have the correct information. If he doesn't have the correct information, how accurate is his load? It's not. It's not really hard to do, but we have to decide up front when we're building a new home or we're doing a remodel, how are we going to build it, how are we going to comply with the energy code, and what are the thermal performance characteristics of that building going to be. And I'm not picking on any one group because it happens everywhere. I just reviewed the 1 million square foot building they're building in Eagle Mountain for Facebook, a 1 million square foot data center. Huge, huge building. And guess what? We have inconsistencies between the energy compliance and the loads and the plans. You got to get it right. If you want the building to perform, you got to get it right. You do you're asking the HVAC contractor to provide you with a system that works, but then if he doesn't have the right information, how can he get it right? If you use this option or any other option, those R values and U factors really need to be on the load calculation. Okay, let's start with some of the other requirements, HVAC requirements, and this is rooms containing fuel burning appliances with open combustion airs. Now I think most of you are familiar with, and it goes clear back into the 80s, that we build a new building, a new home, and we're building it too tight, so we have to bring in a combustion air, correct? So we tighten up the building, then we cut a hole in the wall and put a 6 or 8 or 10-inch pipe and bring air in for the furnace and the water heater. And we have that wide open pipe in the basement inside the thermal envelope. It hasn't made any sense. It never made sense. It's illogical. And so for the 15 code, we finally got it in, and a number of us in Utah and Colorado worked on getting this in the code that basically says, here we have this furnace sitting in a basement with a water heater and an 80% furnace, and you got a combustion air duct coming up back here. You can hardly see it. That's a hole in the thermal envelope. You're not meeting the air sealing requirements. So if you choose to use open combustion appliances that require an open combustion air duct to it, you need to enclose it in a room and isolate it from the rest of the house. And this applies to furnaces, boilers, water heaters. The room needs to be sealed and insulated per the envelope requirements. So we create a separate environment for the room. The door needs to be gasketed. Water lines and ducts, because they are no longer inside the thermal envelope, those components inside that room should be insulated. Now, maybe the inspector is not going to get that aggressive, but technically he could. And where the combustion air duct passes through the conditioned space, it needs to be insulated with an R8. So if you're going to run an 8-inch galvanized pipe through the floor joist in a conditioned space, that has 10-degree air coming in to feed the furnace and the water heater, we need to insulate that duct so that we're not having all this heat loss or condensation or whatever is going to occur with that. So that's the code. Some are enforcing it better than others, but that's the code. Does not apply if combustion air is drawn from inside the home. What do I mean by that? If you have a 2-pipe sealed combustion furnace and you have a water heater and you can do the calculations and show that you have enough volume to draw the air from inside the house, you could technically do that. But the only way you're going to be able to do it, if you go to the fuel gas code, is you're going to have to know the air leakage rate on the building, which is going to mean a blower door test and everything, and then you're going to have to do a calculation that shows you have sufficient volume to provide that. That's a pretty difficult process to go through. The exceptions, of course, are direct vent, fireplaces, and stoves. It doesn't apply to those. So, just to make sure everybody's clear, a power vented water heater is not a direct vent water heater. It's still drawing combustion air from inside the space, and you're going to need to make sure you provide some method of providing combustion air to that space. Now please, if you have a comment or question, feel free to raise your hand. Here is a direct vent, a pipe bringing air in and a pipe taking the exhaust out, correct? It's sealed combustion. The flame is never, the interior environment of the home never sees the combustion process. It's isolated through this direct vent. And of course, the direct vent furnace, where we bring air in and then back out. Sealed direct vent. Now, while we're on this slide, and I probably should have put a little bit more in, but in the interest of time, I did not. The typical 95% efficient condensing furnace for years has had this little burner assembly inside a little sealed box. And you could open it up and you could see the little sight glass and you could see the flame in it. The last 2-3 years, most manufacturers have said, you know what, this is kind of a pain for us to create this. It makes it a little bit difficult to work on. And so what we're going to do is we're going to seal this whole compartment. So this door is gasketed when you put it on, and it becomes direct vent because this compartment is sealed. Well, we have a bunch of knockouts and stuff in this furnace cabinet, and you have a gas line that enters. The manufacturers have grommets and plugs and everything to make sure you maintain the integrity of that sealed compartment. Inspectors, you need to be watching for this, because if they're not using the grommet, if they have a 3-inch opening knocked out and it's not plugged, you are not a sealed combustion furnace. And in fact, if Steve comes out and does a test on it, he might find that we're sucking air in through the pipes into and making it harder to pass your test. And I don't know if you've encountered it yet, but you probably have. And it's a significant leak, isn't it?
Well, it can make like an apartment.
Uh-huh.
Even if it's outside, I mean, it's supposed to be outside anyway in the
Yeah.
apartment. But if they do that in the apartments, it'll fail the blower door.
Yeah, it fails the blower door test if you don't do that. So everybody out there, HVAC people, builders, everybody, when we're doing these, when we install these, let's install both pipes, but we need to make sure that compartment's sealed. And if you go to the manufacturer's instructions, it's all there. They provide the grommet, they provide everything you need to make sure that compartment's sealed. Very important thing. There's thousands and thousands of them out there that are not sealed. So let's talk a little bit. I just touched briefly on this before, but I want to take a minute or two and just talk about, I'm obviously old enough that I remember the initial energy challenges we faced in the 70s. And some of you too. I remember when gas went from 30 cents a gallon up to like 60 and 90 cents a gallon, and it was brutal. Well, one of the solutions to that energy crisis was turn down your thermostat in the winter to 68 and turn it up to 78 or 80 in the summertime, and we're going to save energy. Well, I'm spending so many years as an HVAC contractor and trying to guarantee the comfort of individuals. I don't believe that that's the correct solution to really a good, wise energy policy. I think the best approach is we build a good envelope, we build a good HVAC system, we provide the comforts that we want. People today are way more demanding they were in 1972 when I first started doing HVAC, that we never set air conditioning on anything, even a home in Pepperwood, until after they would see if they could make it through the summer without air conditioning. You don't build a tract home today without air conditioning, do you? The public expects comfort, and that's what we're trying to focus on, is giving them comfort. And so with that, I think 99% of the population doesn't want to do crazy things to try to have the very most efficient home. We want to pay a low utility bill. We want to have a home that's comfortable, but we want to have the comfort kind of on our own terms. And so I am not going to be the first person, even though I'm an energy code geek as much as anybody in here. I'm not going to build me an off-the-grid PV home that I can do everything with electric, because number one, I like to barbecue, grill, and I grill with natural gas, I cook with natural gas, and the third, and the one that my wife would kick me out the door if I said I was going to do away with it, is my tankless water heater. Has anybody ran out of hot water in the last 3 years? Some of you have, I bet. But if you have a tankless water heater, you did not run out of hot water. And I have a Renai 98i tankless water heater. Yeah, I do have an 80% efficient furnace still, but I could stand in my shower for 4 months and never run out of hot water. Is that right? Absolutely. We don't have to wait after a load of laundry and someone else bathes and the dishwasher runs for a half hour or 45 minutes to have enough hot water to take a shower. You take a shower when you want to. You fill the tub when you want to. You do the laundry when you want to. And it's ultra low NOx. It's the cleanest burning water heater you can buy. And it's efficient. It's 95, 96% efficient. Now maybe you want that total electric, and I'm not trying to pick sides, because I think PV and central air conditioning and all these things have a big role. But what I am saying is we want comfort. My dad, I might have mentioned this to some of you, my dad's almost 95 years old. Fought in the Battle of the Bulge. Everybody's seen some of the shows about the Battle of the Bulge and how cold it was. Dad almost lost his feet, and he still has problems with his feet from however many years ago 1944 was, because his feet were almost frozen, in that month, December, January of 44, 45. Am I going to tell my dad, Dad, you need to keep your heat at 72 degrees so you save energy? If he wants his house at 78 or 80 for his comfort, I think he's earned it, don't you? I think we need to keep that in mind. We kind of sometimes might get a little aggressive that we're going to save the world, but we also got to understand that people want to be comfortable. I was a little leery about it. I heard horror stories that if you don't maintain it and stuff, it's not going to work well. I put a water softener in when I put it in. It's 3 years old now. I did flush it a couple months ago. I got almost nothing out of it because I put a water softener in and when I installed the tankless water heater. So what I'm saying is there's ways we can still enjoy our comforts and be energy efficient. Any questions? Let's talk about duct insulation. The code has for many years said R8 if it's outside the thermal envelope, except for a crawl space, it can be R6. I'm telling you right now, that's not enough insulation for duct in an attic, and we'll talk a little bit more about that. In the 15 code, there's a change that says if it's 3 inches or if it's under 3 inch, so some of these high velocity systems, it's pretty hard to get R8 out of those, and those will let you go down to R6 if it's less than 3 inches. And even down to 4.2 if you're in basements or other crawl spaces and stuff like that. A note though, some of you that are involved in commercial work, if it's outside the thermal envelope, in a commercial building, it's R12. So if you're running an R8 flex duct, you're going to have to add some extra insulation. This is an important requirement. We see, and I see this a lot, I had to kick it in the butt. I've had a number of people call me up and say, hey, I think we need to, I'm having everybody raise the flex duct up out of the insulation so that we don't reduce the insulation between the ceiling and the attic above. So we want 38 or 49 in the attic. If we put the duct down in the insulation, maybe we're going to have a little bit of reduced insulated value between the space and the attic, and maybe you will or maybe you won't. But if you're raising that duct up into the attic where it's exposed to 150-degree air all the way around it, you are going to have a horrendous amount of heat gain in the summertime. Horrendous amount. I've looked at a lot of load calculations in St. George area where everything's in the attic, and between 25 and 50% of their heat gain is coming from the duct and the air handlers in the attic. They're throwing hundreds of dollars away every month because that stuff's in the attic. Just throwing it away. Do we have any place in a building that we allow as little as a low insulation as low as R8? No.
Under the slab.
Maybe under the slab, where we have 55-degree and 70-degree, where we have 15-degree temperature difference. But what do we have with a flex duct in an attic in St. George or even here in a dark building, a dark shingled roof with not maybe enough ventilation, and it does hit 140 and 150 degrees. We have air inside that duct that we're trying to cool the space that's 50, 55 degrees. And then we have 150 degrees around it. We have 100 degrees of temperature difference and only trying to stop that flow of heat with R8 insulation. Everybody get what I'm saying? We have a huge amount of heat gain that our air conditioner has to overcome. And it literally is at least 25% and often way more than 25%. You put in a 5-ton air conditioner, 2 tons of it is just to overcome that heat that you keep gaining into your system. There's so much wisdom in getting the ductwork out of the attic. I mean, it is hundreds of dollars a summer. It seriously is. And smaller systems and everything else. This is why we need to do a load calculation so we really see what we have. And let me just take that a little further. 25 feet of 8-inch flex, if you're suspending it up in the attic like this, and you do the math, the exposed surface of that 8-inch duct is 52.25 square feet. So that 25-foot rod of 8-inch, we have a surface area of 5 by 10 feet for heat to transfer in and use up our cooling. Very, very important thing to think about. And in fact, it's so important that it's really becoming a big discussion in the code development process in ASHRAE and all over the place. There is a lot of wisdom if you have to put it in the attic, is you bury it in the insulation. Now someone's going to say, oh, but you're going to have condensate. Not in Utah, and not even in Houston if you have the vapor barriers. If you do it right, and you have to put it in the attic, you need to bury it in the insulation. And if you're worried that, oh, well, I have R38 or R49 here and I don't quite have that much here, how much does it cost to have them throw a few more bags in there when they blow the attic? Almost nothing, right? When I first started doing inspections in 2005, I went out on the first home that was a 2-story that had duct in the attic, and I asked the builder, I says, well, where's the ladder? And he says, for what? And I said, I need to get up in the attic and look at if you sealed the ducts in the attic. Well, no one looks at that. They look at the basement. Well, where do we really need to be worrying? We need to be worrying about the stuff that's in the attic that's outside the thermal envelope. Okay, I'm going to load these up because I got a lot to cover in the next 15 minutes. Okay, duct testing. If you put that duct in the attic, the code says you have to pressure test the duct to make sure it isn't leaking too much. Period. That's not an option. If you have currently 65% of your duct inside the building or 35% outside the building, you have to test your ducts. Without amendments, you test your ducts. We don't care where they are. But with the amendments, it's getting tighter and tighter. That it used to be you could have 50% outside. Now you can only have 35% outside the envelope. In January, it drops to 25%. Mandatory that you have your ducts tested. And Steve does those tests too. Steve?
Your combustion air, unconditioned mechanical room with all the ducts in it and the furnace, does that fit into 35%?
His question is, okay, if we put the furnace in that little room that we just talked about, do we now have to test it? And actually what the code says, if the air handler's outside the thermal envelope, you have to test it.
So is that outside the thermal
Technically, it's outside the thermal envelope and it should be tested.
Right.
Now, I don't know of that many people that are enforcing that. And I'll be honest with you, when we wrote it, we weren't even thinking about that. But you know what the solution is? Direct vent. Troy?
I was going to say, so does that mean that every 80% furnace should be, the system attached to any 80% furnace should therefore be subject to duct testing?
If they comply with the code the way, if they locate it outside the thermal envelope, technically they should. I'll be very candid with you and very honest. We proposed this, number one, to address a problem of a big hole in the envelope. Number two, to get people to think really hard about doing direct vent. It's 2018. Direct vent appliances really became prevalent in the market in 1982, 83. There's no need to be doing open combustion. And by the time you enclose appliances in a furnace room, seal it, weather strip the door, do all those types of things to it, you could have paid the extra for a direct vent furnace and direct vent water heater.
15% savings on your gas bill every month for the life of your home.
Yeah, and you're saving money every single month with operations. So it's really kind of a no-brainer, but yeah, it's, I mean, building inspectors are trying to get the word out, and some of them are trying harder than others. But yeah, theoretically, realistically, if you follow the code for the furnace room thing, and you're putting in an 80% furnace and you're locating it outside the thermal envelope, you need to blower door test the house.
How much more are the low-NOx water heaters compared to the regular water heaters? Do you have an idea?
Yeah, and everything's supposed to be low NOx now. It's a little bit, I've heard anywhere from $20 to $100. The places that have been requiring them for a long time, where that's all they bring into the market, it's almost negligible because that's all they bring in. It's not the quote special order thing.
It only stays low NOx for a few years.
Yeah, if they're using
Like
the
that
little
water
catalytic
is
fin thing,
burned
yeah,
up every time
yeah.
you take one out.
yeah. But anyway, that's a big thing that we should be looking at. And actually, it's been weakened to the point. I'm going to just load these up because I need to stop at noon, right, Becky? The standard is pretty loose. By amendment, what the code says is you shouldn't have total leakage. your total leakage should be less than or equal 4 CFM per 100 square feet of conditioned floor area. And it's been amended to 8. So at 8 CFM per 100 square feet of floor area, if you have a 2,000 square foot home, you are allowed 160 CFM of leakage in your duct system. Now let's think about that. 160 CFM of leakage in your duct system. That's taking a 7-inch pipe and hooking it up to a hood in the outside wall, and anytime your furnace turns on or your air conditioner turns on, we throw that 160 CFM outside. Is that a lot of leakage? The code is saying, no, you should only leak 80. If you're leaking it into an attic, you have a twofold problem. You're throwing away air you just spent money to air condition, and at the same time, if your return duct's leaking, you're doing what? You're bringing in air that is not 75 or 78 inside temperature, but it's 140 or 150 outside, and you're adding that extra load to the air conditioner. So between duct leakage and poorly insulated duct in the attic, we're just compounding the problem. Make sense? It doesn't make sense that it's happening, but it's exactly what's happening. It's really a big thing, a real big thing. We can build the very most insulated thermal envelope, and then we can screw it all up with our HVAC system. And we can have enough duct leakage in an attic that it offsets all of the cooling capacity. I've been on systems before where someone's broken a return air duct off in an attic, and the return temperature coming back to the furnace is 110 degrees. No air conditioner is going to drop at 20 degrees, so you're going to get 90-degree air coming out trying to cool your home. This air conditioner simply can't do it. So the duct blaster test is required, and some of you have seen this. You simply pressurize. You block off the supplies and the returns, you pressurize the duct system, and you see how much it leaks. Amended out the code for a couple of code cycles that said now you can't pan floor joists anymore, you can't create plenums, and that's been amended. You can use them, but if you're going to do them and you have to be pressure tested, you better make sure you seal them real good, because they're going to be really hard to pass the test if you don't have those sealed up. I just threw a couple of pictures in just because I thought they were interesting. This is an inspection I did just before I left the county. Can you see how far that piece of flex has been crushed by that? It even gets better when we go to this picture. This is a 4-inch run going to a little powder bath, and it's squashed down to about 1.25 inches. Builders should be looking for stuff like that. HVAC contractors obviously should not be doing something like this.
Plumbers shouldn't be doing it.
This is a team effort to solve these. Now, when I was in the business, they made straight boots, and I think they still make straight boots, and you can go from round to rectangular, and you can get past these things. Yeah, it's going to take $10 worth of material and a little more time, but you do have ways doing this. When we do this in an HVAC system, it does not comply with the requirements in the energy code or the mechanical code. Ventilation. We're going to talk really quickly about this one. I'm going to load them up because I want to spend the afternoon talking, that last hour speaking a little bit about load calculation specifically. What the code says without amendment is, in Utah, every home is supposed to be blower door tested. Now we have an exception, an amendment that says, well, you can blower door test, or you can do a comprehensive checklist. You can make sure all your rim joists are sprayed with foam and all this sealing takes place. But the code without amendment says you have to blower door test the house. And it says you have to, in Utah, test to 3 air changes per hour at 50 pascals. So you have to test to 3. But in the mechanical code, there's a trigger that says if you're tighter than 5, which we would be in everything, if you're tighter than 5, you have to mechanically ventilate your building because your building's too tight, and you're going to have moisture problems, you're going to have air quality problems, you're going to have all these problems in the house because we don't have enough fresh air into the house. So by amendment, those two numbers were reversed. And so it says you only have to test to 5. If you test, it's an option. You test to 5, but if you go down below 3, then you have to mechanically ventilate. And some of you are going, well, what the hell's mechanical ventilation, right? You have a comment,
Say
Bruce?
again. So I thought as I read in the book that if I tested below 5, then I had to do the mechanical ventilation.
That's what the code says.
Okay, that's what I thought I read.
That's what the code says. The amendment says 3
Residential.
on residential.
I'm glad still it's residential.
Yeah, the amendment actually says, oh, no, you don't have to do it till you get to 3. But I've heard this from builders. They're saying, well, you know, I blower door test myself. I didn't tell my inspector because if the inspector doesn't know, how does he make you do mechanical ventilation? But I'm finding that when I'm down close to 2, that I'm having moisture problems and all this stuff that are visible. Well, if you're seeing the moisture, you have bigger problems in your wall cavities. Is that a safe assumption? So what I'm saying, with the way that they're amended, you need to be real careful because if you're building a house that's really tight and you're not providing mechanical ventilation, you are going to have some moisture problems in your house. In fact, you always have to be careful with our cold climate of where we are going to condense in our wall cavities and in our ceiling cavities. It's a big deal that we really need to be thinking of. Troy?
And isn't our blower door threshold dropping here in a couple months?
And our blower door threshold drops from 5 to 3.5 January 1. So what is mechanical ventilation? Mechanical ventilation is some form of exhaust, supply, or supply and return to where we bring in a specific amount of fresh air from outside at any one time. Let me explain this a couple ways. If we have an exhaust mechanical ventilation, we put a nice quiet fan in the bathroom, master bathroom or whatever, and we set it to run continuously. And we have a formula in there on how much CFM we need to move and stuff like that. And that fan just runs all the time. So what does it do? It exhausts a certain amount of air out of the building and it leaks in replacement air. We are mechanically ventilating. We're exhausting and we're replacing it with fresh air that leaks into our building. Or we can bring in some air into our air handler from outside, set it to run continuous or set it to run 1 hour every 4 hours, and pressurize the building, and we leak or exhaust some air out of the building by leakage. Or we do what we call heat recovery or energy recovery ventilator, where we exhaust, for instance, a 50 or 80 CFM out of the building. We bring a replacement 50 or 80 in, and we recover the heat or energy out of that exhaust air to temper the air that we replace it with. Most efficient, most expensive way to do it. Any one of these 3 provide mechanical ventilation. We should be doing mechanical ventilation in anything that's tighter than 5 ACH 50. Troy?
So we've run into some trouble lately where some properties up in the Park City area have the positive pressure ventilation system, and the failing blower doors because we're just sucking all the air in from through the HVAC system from the outside. And as we're trying to identify leaks, plug up that thing on the outside, and then the home does just fine. But of course, you can't plug things up for blower door testing. So we've got 2 different aspects of code that are kind of fighting each other. From what I've seen with the positive pressure mechanical ventilation system.
Yeah. Troy, for those that are watching, Troy mentioned that when we have these, and you're talking this system here,
Yeah.
where we're bringing in air from outside, when you do a blower door test on those, they're failing the blower door test because you have this opening. Now, The code's tried to address that by any intake or exhaust is supposed to have a damper that closes when you're not in operation, right? And you can, by code, ventilate 1 hour every 4 hours, but you have to do it at 4 times the rate so that you still get the same number of air changes per 24-hour period. So technically those should have a damper that only opens when the fan's running.
And they did have dampers. The dampers operated from 10% to 100%.
Yeah.
So even when it's closed, it was allowing air.
Yeah, and it didn't meet the leakage on the defined in the code for the damper. It's a challenge. I mean, again, this is another one of those things, if we really want to do it right and we really want to make sure we protect our building, number one, positive pressure is not my favorite path. Negative is better, in my opinion, than positive, and balanced is by far much, much, much better path.
Well,
Bruce.
In our homes, we put an ERV at the furnace location, and we're putting a 25 CFM continual operating fan in the bathroom. Are we double doing?
Yeah.
Well,
Because of the size part?
the comment is they're putting a small ERV in, and then they're also doing a
Well,
20,
It's the large, it's not the smaller, it's the full, the construct, or
But it's about 70 cm.
a 70 CFM.
okay.
So it's not a very big one. They're doing an ERV to maintain good ventilation through the whole space, and then you're putting a 25 CFM Panasonic or something in the bathroom
Yes.
and let it run all the time. You're not overdoing, because what are you doing? You're doing two things. You're providing ventilation, but you're also protecting your bathroom from moisture. So I don't have a problem with that. I think it's a good way to go.
On the supply that Troy was talking about, I went to the Energy Star meeting, and everybody has new supply fan systems coming out with good motorized dampers. And they're new. It's something that they've just come out with in the last year or so, and so it's probably not being installed. And actually, Brome told me that they're making one for like apartments and so forth that's less money. Okay, it's not the fancy one that you put in your house, but they've got, you can actually set them. They have like a thermostat control, and you can program everything into your furnace, everything with the supply, the new supply fans that they have.
Okay, for those out there watching, Steve mentioned that manufacturers are now coming out with affordable, good supply fans that you basically, like the exhaust fan, it's a supply fan with dampers and controls and everything that allow you to do a supply method that probably could help resolve that. And one more thing on this one, if you choose to do this, that furnace has to have a variable speed ECM motor, has to have a high efficiency motor, because it's really crazy to use a PSC motor that you're running for long cycles that is going to consume so much energy that you need to have an efficient motor in that furnace. I'm just going to hit one or two more things, and then we're going to have lunch. I'll blame it on Becky taking an extra minute at the front or whatever. Couple of things that are mandatory on its controls, and I'm just going to load them up. Everything's supposed to have a programmable thermostat, and the code even tells you what it's supposed to be set at final. I have never once verified if it was set at those, because people can put it where they want to. If you have a air-to-air heat pump, it's required that you have an outdoor stat, which basically keeps the heat strips off if the heat pump can keep up with the load. And those that understand HVAC know what I'm talking about. You don't want someone to flip up the thermostat and kick in auxiliary heat, which is just toaster strips.
Broiler.
Yeah, the broiler, exactly, if you can keep up with it. And those have been an option forever, but they're mandatory. Outdoor reset. If you have a boiler system, outdoor reset. We change our temperature of our water based on outdoor conditions. Right now, you don't need as hot a water as you're going to need in July, do you? And snow melt controls. if you put in snow melt, you have to put in the slab sensor and the controls that measures ambient temperature, moisture, and slab temperature. Mandatory. You can't put a timer, you can't put a switch, you have to put that control in. And that's the first effort. And it's been in the code for a couple of code cycles to at least make sure that if we are using lots of gas to melt snow, that we do it efficiently. So if you got a customer that doesn't want to put the control in, remind the inspector that it needs to be there. And we have some requirements for pools and in-ground spas where you have switches that you can shut it off, or timers that cycle the pumps, so you're not running them all the time, but only when they need to be ran. Okay, that's where I wanted to be by noon, so we rushed it along and made it. So let's take a break. Grab your lunch. We're only going to take 10 minutes. You can finish eating your lunch when I start again. We're trying to keep these down to 2 hours. So grab your lunch if you haven't registered, and maybe you caught those. Let's make sure we get registered. And we'll start again about 1:15.
All right, thank you for attending the Utah Energy Code Lunch and Learn series. Again, we hold these every month on the second Thursday of the month, and please keep an eye on our new website, utahenergycode.com, to learn more about upcoming trainings and to find resources, including today's presentation. Just want to mention again the important role of a HERS rater. A lot of people don't know that a HERS rater is a home energy rating service rater, which is testing homes to make sure that they comply with air infiltration, and as we talked about today, the importance of duct testing. And so they can be a very good ally to builders and contractors when trying to prove that the home is energy efficient and meets energy code. And we have a few HERS raters in the audience today that I just want to thank for attending, and that is Paulette McGee with Energy Inspectors. We have Troy Pressler with Survey and Testing Services, and we have Steve Thon with Provident Energy. And all their contact information can be found under the residential link on the website, and you'll see the list of HERS raters. So just want to mention that since they are such a key component of the building industry. And again, we'll be holding a lunch and learn next month, and then we hope to have a full day residential, or I guess it's a combination, on multifamily for air sealing in December, and that we hope to have building science expert Mark LaLiberte from Construction Instruction, and that one is currently in process and should be the first week of December, but keep an eye on our email blasts and we'll have more information coming soon. So I will now turn over the second portion of our presentation to Brent Ursenbach.
Thanks, Becky. Yeah, and I'm kind of excited about the website that we have available now, even for myself, so I can look and see what we have planned. And I think you're going to have everything on there, aren't you, Becky, as we move forward to the dates and the information. So kind of make it one of those places that you go and check and see what we have there. And like I said earlier, I'm going to be adding some other materials to that website that will hopefully be of value to you. If you think there is something that we should put on there, let me know, and we'll try to do that. So, excuse me. So this second hour, I want to talk about the big part that is such a battle for a number of builders and a number of contractors, and it's just been something we've been fighting for about 8-9 years now, and that's load calculations, duct designs, equipment selection. Just as an introduction, we have had manufacturers have been including in their instructions for decades the instruction that you need to perform load calculations, you need to perform a duct design, and they've listed ASHRAE standards and ACCA standards for a number of years. The first IRC, 2000 IRC, had in it the requirement that you do a load calculation per ACCA Manual J or an approved equal, and that you do a duct design. And then they added a couple of years later that you select your equipment in accordance with Manual S. And I get a lot of people asking me all the time, what's this J, D, and S stuff? And it's basically the Ansi standard for residential design. Now, residential design for HVAC is a little bit different than commercial because in a residential application, we don't have all of the lights on like we do in a store. We don't cook at the hours like we do in a commercial kitchen, or we don't have the number of people in there. We don't have all the computers and everything. Now, we are going to have some of those things. But what the standards have done is they've taken historical data and they've created some simplifications to the system that a home typically is going to have TVs and computers and stuff on X number of hours a day. You're going to produce a certain amount of heat depending on the size of the house and the size of the kitchen. And it gives you some direction on how to perform that calculation. And it has simplified it. Now, some might say, well, that's not very simple. Well, it's a lot simpler than doing the engineering equations for everything all the way through. So we have some tables, we have some information that's been, that's based on historical data, that it does make it a simpler process. And you can do a pretty good job of coming up with an accurate load. So, equipment sizing, the load calculation determines the proper capacity of the equipment. Now, we can look at just in the past 5 or 10 years, and in fact the last 2 or 3 years, we have changed our cooling requirements simply with LED light bulbs. A lot. I mean, a bunch. It's made a huge change. And if you would have told me 4 years ago we'd be buying an LED bulb for what we buy an LED bulb for today, I would have told you I don't think it's going to go that low. But LED bulbs are affordable, and you can get the colors that you need and everything, and they're without question they're very, very effective. Briefly, I've shared this before. My daughter bought a home in Harriman 2-3 years ago. The original owner was an electrician, and there was 96 can lights in the house, and every one of them had an incandescent bulb in it. And I told Chrissy, I said, you know, you really need to change those light bulbs, at least CFL or LED or whatever. And oh, I don't think it's going to make that much difference. Well, she has 4 kids now, but at the time 3 kids. They turn on all the lights and they leave them on and everything. And the power company contacted her and said, you're going to get an adjustment on your equal pay because you're using a bunch of electricity. And so my son-in-law called me and said, so Dad, were you really serious that changing light bulbs will make a difference? Costco has a sale, you can only buy 6 or whatever at a time. And I said, Jared, it makes a big difference. And so he was going to Costco and buying some and then going back in and buying some more and finally they says, well, just fill your basket up with however many you want and we'll do individual sales for each one so you can get your rebates. And changed all their light bulbs, and I forget the exact number, but it was roughly a 35% reduction in her power bill because, number one, the light bulb was using 85% less power, and that 85% wasted energy was what? It was heat. So we had all this wasted heat that was being put into the space that their air conditioner had to try to remove, and so she was getting hit on the electrical side for the inefficient light bulb and then all the expense of trying to remove all that excess heat that they were dumping in the house. Huge difference. So we're doing some things that change load calculations. We have made so much progress on windows in the last 12, 15 years, and solar heat gain coefficients and all that stuff. We've made a huge difference on how much insulation we put in the walls and air barriers and reducing air leakage. Before we started reducing air leakage, at least a third of our heat loss was due to air just leaking in and out of the building. So we've done so much, rules of thumb just don't work anymore. The goal is big enough to ensure comfort, but no bigger. And the sizing is based, and this is what it says in the Energy Code, in accordance with ACCA Manual S based on load calculations, in accordance with ACCA Manual J or other approved methods. And, and then we also have that replacement equipment shall have an efficacy rating equal or greater to the minimum requirement, federal law in that area. So I hear still people say, well, I use a rule of thumb. I've been doing this for 30 years and it's worked forever, and so I'll just use my rule of thumb. And it's 1 ton per 500 square feet or whatever the case may be. That doesn't work. We don't know how much glass we're putting in. We don't know which way the glass faces. There's so many factors that we need to understand. So some of you have seen this, and I even brought one cut out. So here's a rule of thumb. See, I cut those out. Chris, next time you want to do a load calculation, just go stand at the curb and you hold this up and see which box, which house, the house you're working on, fits in. Is that going to work? I hear some chuckling and stuff like that. Yeah, if it fits in this one, that's a 1.5, 2 ton, and here we got 2.5, 3.5, and here we have our 4 and 5 ton. Isn't this what we're doing when we say, I'm going to go so many tons per square foot? It's really the same thing. Yeah, it's a joke, it's stupid, it's silly, but that's really what we're doing if we aren't doing the load calculation. It's amazing of how small of piece of equipment will do the job if you build the envelope right. I mean, it really is. They don't. They don't make it small enough. That's a good comment, Bruce. In fact, next week, I'm serving on a committee for ACCA, and it's called Low Load Homes. How do we address all these homes that have loads that are so small that we don't even have units small enough to fit them? You know, it's true. It's a big problem that the manufacturers haven't kind of stepped up. They have kind of in a way, but even mini splits are too big in a lot of cases. Lots of multi-family apartment projects where you only have one exposed wall and even 1,000 square feet have a load that's 4 or 5 or 6,000 BTUs. And the manufacturers quit making 1-ton condensing units for the most part. So yeah, it's a challenge. And so the industry's aware of it, working on it, trying to find solutions. And I've been beating up when I've served on these different ACCA committees, because I've been on probably every one of a JD and S committee, and every time I have the opportunity with a national, whether it's Rheem, Trane, Lennox, or whatever manufacturer, I've complained that you're not making the equipment small enough. And in fact, some of them are starting to make furnaces that are like 20,000 BTU furnaces and stuff like that, because that's really all we need. Now don't get scared that it's not going to work, because it is going to work if it's done correctly. So the Energy Code doesn't actually say manual D, because that's more the mechanical side of it, but for a system to work correctly, these three work together kind of as a team. We do allow load calculation with manual J. We select the equipment per manual S, and we design our ducts per manual D. And it has been required forever by Energy Star and everything. And it works. Now, I'm sure there's people listening to this that have horror stories about Well, we did our load calculations, we turned them in so that we could get a permit, and I have an upset customer because their system isn't working right. And I'll guarantee you people are going to have systems that don't work right. But the reason they are not working right, everyone that I've looked at, is they did not install the system per the load calculation that someone did for them. Too often, the HVAC guy didn't do the load calculation. He had a third party, and I'm not saying there's anything wrong with that. The third party does the load calculation, and then what was done is not being followed. The equipment isn't selected that way, or it's selected, or they put that extra half a ton that the code official might allow them to do, but they don't make the adjustments in the duct system to carry that extra half a ton of cooling. So a great design doesn't work if you don't follow the great design. Very important, and the most common problem I see is they do not build the fittings the way the duct design said. They put square-throated fittings in the whole job, no turning vanes, no radius throats, and they simply don't get the airflow. Now, the word I've got from HERS raters that have done Energy Star, how often do you get a system that moves 400 CFM a ton, Troy? As he laughs.
Sorry, almost never.
Almost never. It's always less than 400 CFM a ton. And Steve's nodding his head, yes. 400 CFM a ton is a minimum in Utah. We should actually be moving 450 to 500 per ton because our air is thinner and we're in a dry climate, and we get better, sensible cooling with more airflow. So our biggest downfall is crappy duct systems. We're not building our good duct systems. Troy, please.
So let's just say you're building a house and you want to give your HVAC system a fighting chance of working well. What's the best way to go about that? Like, put in your contract with your HVAC contractor, I need 425 CFM per ton of cooling, or specify I need, I want to review the static pressure in the system and the fan curve. How would you go about that if you're kind of a layman and you're like, maybe a neurotic layman, and want to have your system work well?
Okay. Troy's question is, so what if you do if you're the layman, you're building a home and you want to make sure your system works well? Do you put in the contract that it has to move 425 CFM or whatever? Maybe that's what you need to do. Bruce.
The critical path is the envelope, and then you can design this all day long. And if the envelope doesn't meet what you are shooting for, your customers aren't going to be happy because now your system won't perform the level that the paper said it would.
Good point. Bruce said that a critical path here is the envelope. And you're exactly right. And that's why I talked a little bit about the envelope first rather than just jump right into HVAC. This is a whole system. A home is a system. It's not a framer and a drywaller and an HVAC guy, an electrician and a plumber and everything else. It's everything working together. So we can actually guarantee, Troy, correct airflow, but if we screwed up the envelope, we still got a problem.
Yeah, I suppose my question was naively based on the assumption that the envelope was functioning. I see Bruce nodding his head.
Yeah, no.
Envelope is functioning as designed. Sorry, Bruce.
Now, I'm not trying to advertise Energy Star here by any stretch, but was it Energy Star 3 that they put in this big checklist of stuff for HVAC? And what was that list? That was a list of the things that you really need to do to make sure you have that system you're talking about. So I guess the short of it all is, if you really want to make sure your system works, and ACCA actually has, and if you go to their website and spend some time there, they have a quality assured program. They have all these programs that address how do we make sure it's right, and they've tried to get them in the code because this is probably our weakest spot in the code is our HVAC systems. And while I'm on the soapbox, one of our biggest problems is the resistance to education for HVAC contractors. There's, in a nutshell, the biggest problem we have is we require an electrician to go through an apprenticeship and a licensor, individual licensor. We require the same for plumbers and electricians, and we don't require anything for the HVAC guy other than in Utah we require safety training, the RMGA certification, which is good, but it's basically safety training. It doesn't have anything to do with load calculations and duct designs. And those HVAC people that have self-taught themselves and gone through and learned how to do load calculations. I was very fortunate. When I started in 1972, Mel Taylor, who's now passed away, early in my career taught me how to do a manual J longhand, because we didn't have computers then. And we did them with the big sheet, and we looked up everything in the book and we added them up, and we did load calculations. And so I've been doing load calculations as an HVAC contractor for over 40 years. Thousands and thousands of them over the years. And guess what? Invariably, I would go out on a home and bid air conditioning, and they say, well, you're bidding 2 or 2.5 tons. And I just had a guy here that said 5 tons. And I would get some of them, and some of them I did not. But the 5-tonners that I didn't get, that they put in the 5-ton, a large percent of them, I got the call. Okay, they put in the 5-ton and it doesn't work. It's freezing and it's hot and it's cold and it's uneven. And we have this whole multitude of problems. And so I guess to answer your question in long way, Troy, is we are trying on the code development side, ACCA's trying on their side to provide all these resources. And maybe I'll put some of those on the website that you can go to so you can see what, and in fact they have a QI5, I think it is, what is quality installation. And we'll put that on there so you can recognize what it is. And I know that you that are builders hate to have someone calling up and complaining and everything about a system, and the HVAC guy says, well, the problem is you made me do this load calculation. You wouldn't let me put in what I wanted to do. And you know, our HVAC people generally don't understand what the load calculation is, what the duct design is, and why we need to do it that way. Steve?
But can't you design it wrong?
You can design it wrong if you don't follow the procedures correctly. Absolutely. And in fact, that's why I've looked through thousands of load calculations in the last 8-10 years. People have sent them to me and everything else, and I glance through them and I find things that are flawed in them, but I don't have time to roll out a plan and everything and go through everything. But you can generally look at it and look at the size of the home, and you can tell if it's close. But there's always the chance that someone's going to make a mistake, and so I've always allowed, hey, if you want to put in an extra 1/2 ton just for comfort, go ahead, but make sure you make your duct big enough to handle that extra 1/2 ton.
But isn't there stuff like, let's say manual D over there, okay, where you don't have turning main, they don't put that kind of stuff in the calculation, right? They put in the square corners and they do all this kind of stuff. And then it's still not gonna work. If they get everything matches, J, S, and D match, but it's still bad.
Well, and I'm not sure I understand exactly.
But where do you get the person that's really qualified to do the manuals?
There's some people out there that are pretty qualified, and what you need to ask for is when they give you the duct design, you need to ask for fittings. Have them identify the fittings, and Right Soft and I think Elite, both, you can identify the fitting. You can identify what type of fitting. And that's the biggest problem. You put in a square throat, inside throat is square versus radius, and you can increase your resistance by a factor of 4 or 5 just by putting those fittings in. A square-throated plenum, and I don't have slides in here for this, but the question was asked, so I'm going to talk about it. You come up off a furnace, and then you turn with a square 90. That's equivalent, making that bend to 120 feet of straight duct. That's the friction loss making that turn. So if you have 2 or 3 square-throated 90s, immediately after a furnace, you get no airflow. And they say, well, we're going to put in a bigger blower so we can force the air down it. All you do is increase the velocity, you increase the turbulence, and you can actually shut the duct system down so it doesn't even work. In a nutshell, that's the biggest problem. If HVAC people and their suppliers, and I've complained to suppliers forever, if you would start stocking fittings that had radius throats or put turning vanes in your fittings, you're going to solve a vast majority of your problems. Plain and simple, it's going to happen.
Turning vanes, the internal.
Turning vanes are those little scoop things that
But they're internal to the.
they're internal to the fitting.
Okay.
I've tried to stay in one spot for our cameraman, but here's a duct elbow, right? So I'm talking about is this. Put a radius on it. Or you put these little vanes in here.
Okay, but the vanes can still be in the squared.
They can be in a square.
That square
Yeah.
for area. Okay, so
Yep.
it is what I was thinking.
And so, yeah, that's turning vanes. The thing is, they're a little challenging to put in like a 12-inch duct. If a 12-inch duct, it's much easier to do this. And this back here, people say, well, we round it back here. Well, that doesn't make that much difference. Air is a fluid. Air moves just like water. If this is a river and you have water coming this way fast, what's this?
Eddy.
It's an eddy. And you drop a fly right there where the water's still, and you're going to get hit almost every time, right? So you throw a lot of fan horsepower at it, so you move the air faster, and what do you make it? Bigger. And so effectively, there's your duct dimension. That's exactly what happens. I had an experience with 73, 74 when my boss took me out. I was just a young kid, and we put in an air conditioner, and it had this type of fitting. We put in a 1.25 or 1.5 horsepower motor to throw a lot of air at it. And as we wound it up, we literally stopped airflow. It was just beating against the top and just all turbulence. It moved nothing. All we did is cut it off like that and change the duct to that. It is so huge. That right there would solve more problems than just about anything else. Now that's not the only thing. You got to be careful about other stuff, but that's.
After that, it's loose flex.
Yeah, flex duct and all this other stuff, and I don't have a problem with flex duct if it's installed correctly. Let's move forward. I beat on this, and I'm going to beat on it one more time. We're behind the 8 ball. We're not going to be successful if we don't make sure that we at least have the right numbers. Bruce mentioned it. If you don't have the envelope right, we're kind of starting behind right off the bat. We got a problem. So if we're putting our 19 in a wood frame wall with no insulation on the outside, then that's the way we should represent it on all the documents. If you're putting 1 inch of foam on the outside, then that's the way you should represent it. If you're putting in 0.28 windows, that's the way it should be on all the documents so that we have a fighting chance of getting this thing right. This isn't a simple thing. This is a complex thing that we go through building a home, and we need to make sure we have consistency across those documents. Design conditions. This is something that people whine and complain a lot about, and I just want to spend just a brief minute or two on it. If you go to Manual J, it has, in Table 1A, it has what conditions you should design for. And it says that we should design in the winter time, Salt Lake City at 11 degrees, and in the summertime for 94 degrees. And there's people out there that are saying, whoa, 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 whoa. I live in South Jordan right over here, and this is at the airport. This is where this condition is. And we always are colder than the airport. And that's a fact. We are always colder than the airport. The airport's the worst place in the valley to take a temperature for design across the whole valley because we have this great big body of salt water that influences the temperature at the airport, makes it cooler in the summer and makes it warmer in the winter. let me just say this. If you're a code official, don't get hung up on if someone designs for a condition that's a little different than it says in Manual J for Salt Lake City or what it says for Heber or whatever, if it's reasonable. These conditions are what they call the 99% value, and what it means is 99% of the time in Salt Lake City at the airport, it's 11 degrees or warmer in the wintertime. 1% of the time it'll go below 11 degrees. And that's based on historical data. When it goes below 11 degrees, it might be for a couple of hours or an hour on several days. You might have every 10 or 15 years where we go below it and we stay there. That's fine, because what happens, we automatically get a 10, 15, 20% oversizing simply because if I do a load calculation and it comes up at 21,000 BTUs, what am I going to put in? A 40,000, 95% efficient furnace, and I have plenty of oversizing simply by selecting the next piece of equipment. So let's not get hung up on this, but also let's not get ridiculous, like I had a guy that sent one to Windy and Midway and designed the summer for 107, and Midway's never seen 100, ever. So pick a good number, just be able to justify it. In my South Jordan home, not too far from here, probably 7 is a better number. 96, 97, 98, I don't even care if they do it for 99 or 100. It's not that much difference, but be reasonable about it and then design from that. What's the load calculation doing? It's looking at the temperature difference. It's looking at the difference between inside and outside and sizing the equipment based on that. So if it's 11 degrees outside versus 7 degrees outside, it's not going to be that much temperature difference between inside and outside. You need to do a room by room calculation so that we know exactly how much air we need to blow to every room. If you just do the whole envelope and say I need 40,000 BTU furnace, well, we need to know how to distribute that 40,000 BTUs around the house. And the Manual J gives you that. So real quick, just touch on what we're doing. Heat flows from warmer to cooler objects. And so like I say, if we have 70 inside and 5 degrees outside, the temperature difference is 65 degrees. And that's the number we use in all of our formulas, is we have a 65 degree delta T or temperature difference. How much heat are we going to be losing through that wall component? And how do we lose heat? So we have a wall here. We're going to lose heat a couple of ways. We have heat transfer by conduction. And basically, we heat up this end of a coat hanger because we're trying to roast a hot dog in the fire. It doesn't take very long for the heat to do what? To transfer up into your hand, right? So a coat hanger, a piece of steel, is not a very good insulator, so we're going to have a lot of heat flowing through it, just like we do on a metal stud in a wall. We have heat transfer by convection. Sure, we have conduction through the wall, but we also have leakage through the wall. Steve and I were just talking at break about the leakage we have in multifamily townhomes where you have 2 walls, and Bruce is shaking his head because it's brutal, isn't it? It's really hard to address the leakage between units when they're testing these buildings to try to maintain some air tightness. And that's why we're going to be speaking about that a lot. So thermal convection, that's the transfer, is we leak heated air out or we leak cold air in, or the opposite in the summertime, we leak hot air in. We have a component of our heat loss or our heat gain for the building. It's like opening the window and just having air coming through. If some of you have seen Mark Liberté as he talks, he gets a big piece of paper and he says, so how big a hole do you want in your house? And then as he talks about air tightness, he keeps folding it up. And so what's the acceptable amount of leakage? Now most of us are going to say, I don't want any hole in my house. That's unrealistic. We're going to have a hole in our house, but how big a hole? So This air sealing that we talked about a little bit before in blower door testing, that is all to address this convection, which is a component of heat loss and heat gain. And then we have our radiant heat. Mostly as part of our load calculations, we're getting it from the sun radiating through the windows, but it's actually a component of the systems you guys do where you actually, for comfort, you radiate heat up off the floor to make people comfortable, correct? So we have heat transfer, heat escapes through walls and openings from warmer inside to outside, and we're losing heat. And we do that in the winter, and so we want what? We want the system size to replace the amount we lose. And that's the whole purpose of load calculation. How much are we going to lose? So how we build the envelope, as Bruce mentioned, how we seal it, how we do all these things, the type of windows we put, the type of insulation we put, all add into the equation of how much heat we're going to lose out of that building. We only need to replace what we lose. So when I say you can have a really small system to heat a really big house, like you build a home out of insulated concrete forms. You know, those big Lego foam blocks, pour them full of concrete, do a good job around your windows and stuff, you're gonna have almost no air leakage, right? And you're what?
You may have to cool in the winter just from your body heat.
Yeah, you might, when it's moderate,
That's not a joke.
that's not a joke. You literally can produce enough heat. When you build a home that way, you can literally produce enough heat living in it to meet your demands. Because we produce heat living in the house. We breathe, we give heat off, we cook, our fridge runs, we have all these different things, and we can literally heat our home off of that if you build it that well. So those are the homes, if you put that 4-ton or 5-ton or 3-ton in those things, they're going to be so ridiculous because they're going to turn on for 30 seconds and shut off, and it's going to be uneven and miserable. So we know everything that where heat transfers. The opposite thing happens in the summer. We have heat coming into our building, and then we want to remove it with our air conditioner. And so we have the convection and the conduction and the radiant heat striking our building and heating up our building and moving through our building components, heating up our attic. And so we're moving all this heat into it, and then we needed to know how much we need to remove it. When we put our ductwork up here in the attic so that it's even gaining more heat, then we have that equation that we have to complete. Internal gains, just want to touch on that real quick, and that ties into what we just said. As we live in a building with our lights and our TVs and our computers and our refrigerator and our freezer and all those things that we do, we shower with hot water, we wash clothes, we add heat to inside the building. We have to deal with it in the summertime, and that's part of our load. Only if you're building that super insulated house do you need to worry about worrying in the wintertime. Any questions on that? I'm going real fast because we're trying to keep this within the time frame. So our infiltration, or the convection that we have in our building, comes through all kinds of places. Steve and I were talking at break. Rim joist is one of the biggest places that we have a lot of air leakage. And the way the code is amended, and this is for everybody out there, if your jurisdiction is enforcing it correctly, if you are not spray foaming your rim joists, you should be blower door testing your house, because you are not meeting the comprehensive checklist that's in the code. And by amendment it says you meet this comprehensive list or you blower door test. Well, one of those requirements is the rim joist insulation has to have an air barrier on all sides. Well, how do you put an air barrier across the inside face of fiberglass in a rim joist? Do you cut a piece of Hvac to fit in there between the eye joists and then caulk around every one of the seams to create an air barrier on that? virtually the only way you can effectively do that is to spray foam the rim joist. So if you aren't spraying foam in the rim joist, then you should be blower door testing the house. And there's a lot of leakage that occurs in that space. But here's all the other places. We know where they are. There are can lights and everything else. You know your can lights are all supposed to be caulked or gasketed, every one of them. Ventilation, we already talked about it. And remember I said maybe supply exhaust or a combination of supply and exhaust. If you are ventilating your house, you should take that component of 25 CFM or whatever it is and figure that in your load calculation that you are doing that. If you're using an ERV or HRV, you can actually take the efficiency of that device and include that in your load calculation. Latent heat. Air conditioners remove moisture. Our climate is so dry that we have very little moisture we have to remove. In fact, the only moisture we remove is moisture we create in the house by living in it, by showering, cooking, and washing and stuff. But with the amount of air leakage that we have, even in a relatively tight house, we really don't have what we call a latent load or a moisture load in our homes. In fact, I'm going to jump back real quick. Design grains, 45% relative humidity. It's a negative number. What that means is our climate in Utah is drier than we really want. It's drier than the comfort level we want. And so if we want ideal comfort, we actually need some extra humidity in our homes just to get us to the ASHRAE standard for comfort. So when people tell me, well, I have a huge latent load in my home because we cook and shower a lot, our air is so dry outside, we can account for that with that.
Evaporative coolers still make sense in those situations.
Yeah, in fact, I mentioned that I did the review on that Facebook building. It's almost 1 million square feet. It's 950-something thousand square feet. And guess how they're cooling the data center? Evap, 100% evap. They have cooler pad running the whole second level of this building. Is shaped like an H, but running the long legs of the H. You have filter banks and evap cooler pad and all these fans and everything, and you have 1,000 feet of filter and cooler pad running the length of that H on each leg of that. It's the most incredible thing I've ever seen. But they're cooling the whole thing evaporatively because why? Because we have a negative 24 grains of moisture, and they can cool that building and still keep the humidity low enough with the right controls and the right fans and the right exhaust and the right mixing. It's not a simple evap cooler like you stick on your roof. It's a very, very complex system. It took me about 25, 30 hours to figure out what the hell they were doing in this building. But we have a dry climate, and evap will work. We don't have to remove moisture. In other parts of the country, they have to remove that moisture, and it takes cooling capacity to remove it. We have on a load calculation a sensible heat ratio, and everybody likes to get as much extra cooling as they can. And so they say, well, we're going to have a little bit, and so I have allowed a 0.85 sensible heat ratio, which means they could have 15% of their load latent, when in fact, most of the time we have no latent, and our sensible heat ratio should be 1. If you have questions about this, send me an email and I'll send you some more information on it. Okay, the last thing that I wanted to talk about with you on, and we're just about out of time, but I have in the slides, and you can't read it, but these are actually on the website right now, Becky. I sent you these. And it's a little checklist. And I might have brought a copy. Well, that's the one page of the manual J. And then there's the back side, and it's a checklist. And it goes down through the things that you should be checking. And this kind of answers your question, Troy, some of the things you should be doing. Indoor design conditions, outdoor design conditions, U values and solar heat gain coefficients. I think I've kind of beat that one up a little bit, haven't I? You can do shading and overhangs and all that stuff, which direction it faces. Here's our skylights, here's our doors, our wall insulation, our ceiling insulation, our floors, and the questions to ask as you go down through it. Now, some of these are a little less important than some of the others. Like, I don't get really, really hung up on if they have curtains, drapes, or any of that stuff. I don't think we need to worry about that in our load calculation. I figure them generally without drapes because I have no control over if they're going to close their drapes. If the house has a real big west load, I would always tell the people, you need to put some type of covering or shading on those because it's going to be impossible to keep it cool if you have sun beating through huge windows facing west. I mean, it just doesn't work. So anyway, there's that checklist. I'm backing up. The front page of this is one of the best synopses I've ever seen on why we should do a load calculation. I mean, it really goes through it and it explains it very, very well. Again, this is on the website, so you can go to it. You can print this off, as many as you want. If you have trouble getting it, send me an email and I'll send you the PDF on it. Very important document. Gives you what to check. Manual S. That's the other. This is how you select equipment. Again, a description of why we want to select equipment properly and what we need to look at. And then it even goes into a checklist on how we verify that the equipment's been selected correctly. These 3 pages will help you bring all those pieces of a load calculation, duct design, and equipment selection together. They are very, very helpful. Keep in mind that they're going to talk about latent loads, which we almost never have to worry about. And then our duct design, same thing. Why do we want to do it? And our inspection checklist on the back. And what do we need to be looking at? I just want to speak briefly. We started 5 minutes late, so I'm going to take a few extra minutes. Any duct design is going to look at, have a friction rate worksheet. And what it's basically saying is, we have selected a furnace that has a certain blower in it, and it can move so much air depending on how much resistance is placed on that system. Does that make sense? You put a garden hose on a faucet and you're going to limit how much you can flow depending on what type of hoses and what type of tees and fittings and everything in it. So the manufacturer has blower data that says at 0.1 inch of external static pressure, we're going to move, for instance, 2,400 CFM of air, but when we have 0.7 inches, we might only move 1,400 CFM. And this worksheet helps us pick the right equipment and build the right duct system and do everything else. And so we have, at 0.7 on this one, we'll move 1,200 CFM. We have to account for everything we put in the airstream that'll resist airflow. And so the first thing it has is an air conditioning coil. That's going to resist airflow. And so you have to account for it. A filter. If you go down to Home Depot and buy that super duper air filter that's pleated, allergy free, everything else, you might have enough resistance in their air filter that your your air conditioner won't work. You're going to restrict airflow so much that it's simply not going to work. So you need to make sure that you're putting the right air filter in it. I always sold with big, thick air filters. In fact, the picture of my tankless water heater, if you look real close, you might even be able to see one of those cabinets underneath with a big, thick filter on it. What you lose through your registers and grills, there you drop 0.5 inches of water column. You only have 0.2 left. You only have a little bit of resistance left, and you have to make sure you design your duct system so you don't have any more resistance than that. And that's where we screw up. We don't account for our devices, and then we definitely don't build our duct system based on what that number is that's left over. We could spend 5 days talking about this and just brush the surface. But I think this is a good, I hope this has been a good review of some of the basics and what we're looking at when we do an HVAC design, and why the energy code has made it such a big point is that we need to make sure our HVAC system integrates with that envelope that we built. These are really great worksheets. Like I say, go to this website right here. It's new. It's how long has it been up? A month?
Yep.
It's been up about a month, and we're going to be adding to it. You have the ability to ask a question, and
Yep.
and then when time permits, I'll respond to it, or we'll get someone else to respond to it. My 2 email addresses, my phone number. Again, an email works so much better because I'll probably respond quicker. Thanks so much, and great to have you, and we'll see you next time.
Thank you.